Guys, hi, welcome back. So in the last video, we have solved questions related to the quantization of charge, right? So in this video, we will solve the questions related to the Coulomb's law. So let us see the first question here. It is say two small balls having equal positive charge Q. So the first part of the question is what? We are having two small balls and it has how much charge? Capital Q charge. And this capital Q charge is positive, okay? On each suspended by two insulating strings of equal length L. Okay, so these two balls are suspended by two insulating strings of equal length. You can see the spelling of insulating is wrong here, so it will be LA. Okay. Now you see from a hook fixed in a stand. So these two balls, which has plus Q charge, they are suspended by two insulating strings of equal length L, and it is suspended from a hook fixed in a stand. Okay, and the whole apparatus is taken in a satellite. So this setup is taken to the satellite. This is what it is said. And since here it is already mentioned that it is taken in the satellite, so this is a condition of state of weightlessness. That means we will take the weight mg to be equals to 0. So what you are asked to calculate, find angle between the strings and tension in its string. So you need to calculate the angle between the strings and the tension in each string. So you need to calculate T and theta, right? So we will understand the question once more. Okay, we will draw a figure for the problem. So we will just draw two balls, okay? I'm drawing this is to be one ball, right? This is to be other ball. Both the balls are having equal positive charge, that is capital Q, right? And these two balls are suspended by two insulating strings. So we can just take this length and this length, okay? Taking the distance between the two charges, okay? This length is L, suspended by insulating string. This is also L, all right? So there is a hook. You can just think that there is a hook here. I'm just drawing it straight because of the electrostatic force of repulsion. Okay. So now if you see here, this charge Q and this charge Q, they will experience a electrostatic force of repulsion in this side, and this charge will experience repulsion in this particular side. And the tension T will be along this side, right? This is what it is. So the entire situation is in the state of weightlessness. So we will write the weight first. We will write the weight is equals to mg, which is equals to 0. Now you see, since these two balls are experiencing repulsion, okay, positive charges repel each other, right? So the string will become horizontal. Yes or no? Because due to repulsion, the string becomes horizontal. I'm drawing it horizontal because we know that there is an electrostatic force of repulsion between the balls, okay? And the string would become horizontal for this. And the angle between this, since it will become horizontal, you can see the angle between the two small balls will become 180 degree, because you can see here, this is a straight line, right? And we know it is a 180 degree angle. Now we will see that this side, the electrostatic force of repulsion is acting, and on this side tension. So we can write the tension here, it is equals to the electrostatic force of repulsion. And just we will do the basic calculation. We know the electrostatic force of repulsion is what? KQ. N2 with Q means the product of the magnitude of the charges. So it is Q into with Q divided by the distance between them. And now you see the distance between the two balls. That means two charge balls will become twice L, because this distance is L, this distance is L. So the separation will become 2L. So it is 2L whole square, right? So from here you can write T is equals to, we know K. K is what? 1 by 4 pi epsilon naught. So it is 1 by 4 pi epsilon naught. And this will give you Q square by 4L square. And further you can write T is equals to 1 by 4 pi epsilon naught Q square. This will become 16, right? Okay, and L square. This is what it is. So theta you have directly calculated 180 degree. So you were asked to calculate the angle between the strings. So the angle between the string was 180 degree. And the tension in each string. So the tension in each string is 1 by 16 pi epsilon naught Q square by L square. So this is a really easy question. Just you should understand the question and just draw the figure. Next, let us see two charges of 3 microcoulomb. So this is a microcoulomb. Microcoulomb means that is 10 to the power minus 6 coulomb, right? Each are lying in air at a distance of 0.30 meter. So this is the separation between the two charged bodies. You are asked to calculate the nature and magnitude of force between them. So you see two charges of 3 microcoulomb is given. 3 microcoulomb means both are like charges, so there will be repulsion. So the second part is, the first part is done. The nature of the force is what? Repulsive. Okay, because we are having positive charge. Now we will calculate the magnitude. So we will just use the Coulomb's law, right? So what is given to us here? It is given Q1 equals to Q2. That is 3 into 10 to the power minus 6 coulomb. Converting microcoulomb into coulomb, you can take this to be, this is the charge 3, just a second, 3 micro coulomb. Here also this is 3 microcoulomb. This charge is Q1, this charge is Q2. And they're lying in air. That means the medium is what? Air. All right. So here again it is said the separation, that is the distance between the two charge bodies, is 0.30 meter. That means this R is 0.30. What do we know by Coulomb's law? What does the Coulomb's law give us? The formula for electrostatic force? We know Fe, the electrostatic force, is 1 by 4 pi epsilon naught, the product of the two charges divided by the distance between them, right? We are writing epsilon naught because this is, because the two charges are lying in air. So for air, we are using this particular question, right? Sorry, this particular formula. So Fe, so 1 by 4 pi epsilon naught, we know the value is 9 into 10 to the power 9. The product of Q1 and Q2, it is 3 into 10 to the power minus 6 into 3 into 10 to the power minus 6. And R square. R square will be what? It is 0.30, which I can write 30 by 100 whole square. All right. So now we will do the calculation, which is actually very easy. So here if you see, it's 9. Again, 3 3 is 9, right? And this side you can write 10 to the power minus 12 plus 9. And in the denominator, what you are having here? 30 into with 30. Okay. This is 100 square, which will become what? This is 100 square, right? So it will become plus 4. Square and square will become 4, right? And from here, what we will write? Fe is equals to, this is 9, right? So 9 into 9, I'm keeping as it is. This I'm writing as 3 into 3. Okay, into 10 square. So again, it will go to the numerator. So it is minus 12 plus 9 plus 4. And this will go to the numerator. So it will go minus 2. Clear? So 9 plus 4 is 13. Again, minus 12 minus 2 is minus 14. So this will give us minus 1, 10 to the power minus 1. And this is 3 3s are, again 3 3s are. So you will get Fe is equals to 9 into 10 to the power minus 1 Newton. That can be written as 0.9 Newton. Clear? So this is the magnitude of the force, and the nature is what? Nature of the force is repulsive. It is repulsive. Okay. That means two like charges are repelling each other. Clear? So I think this question is very easy. In the next video, we will see more sums. That's all in this video. Thank you so much. Have a good day.